All right, general foundations kids, we are going to make our model that shows the Liberians how they can address this problem. This model is going to show the problem that you've outlined as well as your research. Okay, so looking here at the beginning, analyze the problem. Oops, I don't want that. There we go. Analyze the problem you've defined. Now, what is the problem you've defined? This is where you can go to number 1. Okay, on day 1, we wrote a statement outlining the problem, and then on number 5, you answered that problem with the help of your research that you did on the symptoms. Okay, so you're trying to model the problem and to show the Liberians what is causing this disease. Okay, so you're going to make this model. You can make it drawn or computer generated. If you're going to make it computer generated, I'd like you to approve it with me. Okay, and what you're going to show is how, I don't know what happened there, that was weird. Okay, we're going to show how is the disease transmitted. Okay, this is what we call a disease transmission system. Now, this assessment is going to analyze your ability to demonstrate how systems interact, okay, as well as your knowledge of the parts of a system. All right, so you should address all of the parts of a system. Okay, inputs, outputs, boundaries, controls, feedback loops, and we're going to include components. I know here it says components, and that's a given because you already have the components provided, but those need to be shown in your model. You also must explain the role of these participants or the components in the disease transmission system. All right, now how are you going to show these components? You're going to create a model. All right, and I would like this to be a physical model. A conceptual model is might be your first thought. However, with a conceptual model, it's harder to show these guys. Okay, I would like you to have figures or pictures that are demonstrating your knowledge of these as well. Okay, and these are only the basics. You can add more. So you might have to do a little bit of research on how are these 4 key players interacting. All right. You're going to show relationships and interactions between the components by a number of tools. One of them might be arrows. You've used arrows before in your body system model, and annotations. Now, annotations are very, very, very short descriptions. An example of an annotation is if I'm making a model of myself. So let's say this is me, Mrs. Schuessler, and I'm making a model of walking to school. So let's say here's ICS. There's my model of ICS. Okay, an annotation would be this. Mrs. Schuessler walks to ICS. All right, if I take a bike, I could throw my bike in here. Here's my seat. Now this bike has now taken the place of my annotation. All right, so as you're doing your models, think of how many ways can you demonstrate these relationships through arrows and annotations. You can include figures, but we're really wanting to see is how can you show me your understanding of the interacting parts of a system. Okay, now you can just Google this picture, this system, because there is a picture on Google that shows how they are all interacting. If I see the same exact picture in your model, that is plagiarism. Okay, you are not just copying and pasting the picture that is on Google. All right, now remember, the whole point of this model is to tell the Liberians. Remember these guys? Remember my friends? How can we teach them about the disease and how it's transmitted? Okay. This is actually what public health workers will do. Is if they're studying an outbreak of a disease, let's say for example Ebola. When Ebola was very, very bad in West Africa, in this same area in Liberia and Guinea, which is where it happened. If you you remember that. There were many public health efforts where people will go and educate the people, the locals, of how they can prevent the disease. All right, so this is something, what you're doing right now is what real scientists do, okay? So this is, if you're thinking of a career that you'd want to have in science, this process of identifying an outbreak or a disease, educating the population on how they can prevent it, and how it's transmitted, this is something real life people do, okay? So we're trying to expose you to real life scenarios. Okay, now we're going to move into the last part of your project, and that is preventative measures. All right, you're going to suggest 2 preventative measures that might help the town of Monrovia to avoid further outbreaks of the disease. Each preventative measure must include 3 pieces of evidence. So number 1 and number 2, each 3 pieces of evidence. Make sure your evidence is sufficient to back up your claim. Okay? This should explain the scientific ideas behind why your suggested preventative measures work. AKA, this evidence is going to be supported by reasoning. Okay? We're doing a CER. Okay, so preventative measure number 1, you're going to make a claim. What is the first preventative measure? My preventative measure is blah, 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 blah. This is a preventative measure where it's been seen in this scenario, and this scenario. All right? And then my reasoning to support why my evidence supports my claim. This is why this preventative measure will help prevent further outbreaks of the disease. Okay, this is where you can include, this reasoning is where the scientific ideas come in, okay, where you're connecting your evidence to your reasoning. So claim, evidence, reasoning. And then you'll do the same thing for number 2. You'll have another claim, just a short statement, remember, that just says, this is how you can prevent further outbreaks. Here are 3 ways that I know this, and then my reasoning. All right? And this is why it will help prevent further outbreaks of your disease. All right? So you have 2 CERs to help prevent further outbreaks of the disease. Now, Mrs. Schuessler, how are you going to grade this assessment? I'll show you. You have here's a rubric you can use to analyze whether you are exceeding the standard. Okay, think like A+, A range. This is getting, and then meeting the standard is the A-, B+, B range. Approaching is where we're getting into the C range, and the beginning is the D range, okay? To exceed the standard, you are showing the relationships of the participants in the disease outbreak system, or the transmission system. Their roles are thoroughly explained, not through paragraphs, but through diagrams, arrows, and direction of flow, and detailed annotations. Okay? So we're looking for a fully demonstrated understanding of how the system is, the participants in the system are interacting, and you're showing that through diagrams, arrows, direction of flow, and detailed annotations. Okay? B range, you're showing the relationships of the participants in the disease transmission are demonstrated clearly through arrows and their direction flow as simple annotations. So notice here the difference is detailed annotations versus simple annotations, and we have thorough explanation versus just clear demonstration. Okay? When you get into the C range, we can identify the parts of the system, but as far as how they're associated and interacting, the participants in the transmission of the disease are associated with the components of the system, but we might not see the interaction. Okay? Now, in the D range, you are either missing the components or they're just not identifiable in the model. Okay, so you have obviously not demonstrated an understanding of how these components are related or are part of a system. Okay, that's the first part of the rubric. Second part is looking at the solutions where you're resolving the problem. So you provided those 2 solutions to the how they can prevent disease outbreak. They're explained in detail, supported with sufficient evidence that addresses underlying scientific ideas. That's your reasoning there. Okay, that's how you get an A. A B range, meeting the standard. You provide the 2 solutions, so you make a claim, and it's explained and supported with evidence. Now the evidence there might not be completely sufficient, but you have supported it with 3 pieces of evidence. And the reasoning is provided, but it doesn't necessarily address underlying scientific ideas. Third part, you state the 2 solutions to the problem, but they're not explained well, nor are they supported with evidence. So this is just if you make a claim, or your claim is incomplete, all right, or your evidence is incomplete. Here, you didn't provide solutions to the problem, whether that's you read the problem wrong, or you just didn't follow the prompt, or you neglected to do number 7. This is how you get a D, okay? And then our references and citations. This is the last part. You have provided proper citations in MLA style with minor or no errors, and you've done this for 5 or more references, okay? Easy points there. If you only do 3 more references and you have some errors, this is a B range. If you're just including the URL or you're not citing it using MLA in a non-scientific, non-academic manner, or you only do 1 or 2 references, this is the C range. And then D range, you did not include your references at all, okay? So you can use this rubric to self-check. Okay, I will go back after you make your model, after you do part number 7, when you're resolving the problem, and after you finish your citations, do a self-check. Have you met the expectations for all 3 of these, okay? And that will help you know, what am I missing, what can I add? All right, if you have questions, please feel free to reach out to me. I will be kind of popping around in breakout rooms, so you can just call me in if you have specific questions. Otherwise, you may have at it. Have fun.